Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of calculus. Now, questions like these are often asked in Olympiads such as the International Mathematical Olympiad or the Indian National Mathematical Olympiad. Okay, so if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So we are given a function f from real to real, which is a continuous function, such that for all real numbers x, we are given an integral on the left hand side and an integral on the right hand side. We are asked to find all possible values of f of 0. Now, to solve a problem like this, we are going to take the fundamental theorem of calculus and the chain rule, both of which are very simple. So if we take the LHS, we have d dx. So what I'm going to do on the LHS, I'm going to take the differential over the integral of 0 to x f of t dt, and this primarily gives me f of x. Okay, and on the right hand side, if I do the same, let me say that this is f of x is equal to 0 to x square root over 1 plus ft whole square dt. Okay, so if I take the differential over f df dx is equal to d dx of this expression 0 to x square root under 1 plus f of t whole square dt bracket close. Now this is nothing but root under 1 plus f of x square whole square d dx of x square, which is nothing but 2x root under 1 plus f of x square whole square. You see how I applied the chain rule over here. Now this condition, so we have taken the differential on the left hand side and the right hand side. So this technically gives me that f of x is equal to 2x root under 1 plus f of x square whole square. Correct? Now if we plug in the value of x is equal to 0, because we are asked to find f of 0, right? So if I plug in the value of x is equal to 0, this gives me f of 0 is equal to 2 into 0 root under 1 plus f of 0 whole square is equal to 0. Correct? So f of 0 is equal to 0. This is one solution, but in the question, if you follow, we are asked to find all possible values of f of 0. So the problem does not end here. Okay, so for that matter, we have f of x is equal to 2x root under 1 plus f of x square whole square. Correct? Now if we do f of x square, this comes out to be 2x square 1 plus f of x square f of x4 whole square. Correct? So what happens here is what we call as a recursive explosion, because you're looking for f of x square and you're getting the term f of x power 4 inside. This is an ideal case for recursive explosion. If I write the expression, you'll understand it better. So f of x is equal to 2x under root 1 plus 2x square root under 1 plus 2 power x4 root under 1 plus and dot dot dot. So you will finally see something like this keep happening to you. Okay, so this is a ideal case for recursive explosion, but we know that in the question it is given that f of x is a continuous function. Okay, and to keep f of 0 finite and continuous, okay, f of x is continuous and f of 0 will be finite. Okay, so we have to see that if we plug in the value of f of x is equal to 2x 1 plus 0, this is nothing but 2x, and f of x square is equal to 2x square root under 1 plus 2x whole square. So this lets me, like, if I assume that f of 0 is equal to 0, then I see that it is following a continuous pattern. Let us elaborate this further. Let us assume, I think this will help a lot of clarity in the problem. F of x is equal to ax. Okay, that is linear. F of x is linear. Okay, then we have 0 to x ft dt is equal to root under 0 to integral over 0 to x at dt, which is nothing but a by 2 x square. Okay, so this is your left hand side. Okay, now if I take the right hand side, I will have integral over 0 to x square root over 1 plus ft whole square dt, which is nothing but 0 to x square root under 1 plus a square t square dt. Correct? So if we compare, a by 2 x square is equal to integral over 0 to x square root under 1 plus a square t square dt. Okay, if I differentiate both the sides, I will have ax is equal to 2x root under 1 plus a square x power 4. Okay, now if we solve this, we have a is equal to 2 and root 1 plus a square x power 4. So if we plug in x is equal to 0, if we plug in the value of x is equal to 0, I get a is equal to 2 under root 1, which is implying that a is equal to 2. So I assume that f of x is equal to ax. Now I got the value of a is equal to 2. So this tells me that f of x is equal to 2x. Okay, so I removed one uncertain term which was there, and this is giving me one expression. So it is suggesting that this may work. I'm still not sure. This may work, but I'm still not sure. So if I try, f of x is equal to 2x, this implies that integral over 0 to x f of t dt is equal to integral over x 2t dt, and this turns out to be x square. Correct? Now if I do the same again, integral over 0 to x square under root 1 plus f of t whole square dt, this turns out to be 1 plus 4t square dt. So what we see here is very interesting. We are getting, so this was my LHS and this is my RHS, right? So it is telling me that x square is equal to integral over 0 to x square 1 plus 4t square dt. Correct? But we know that integral over 1 plus 4t square is always greater than 1. That is only then x square will, left hand and right hand side will be equal, right? But this is always greater than 1. Okay, so this doesn't work. It's not work. So we have only one possible solution, which is the f of 0 is equal to 0. Otherwise we will see a recursive explosion happening. Otherwise, okay, so if you do like the video, hit like button and subscribe to our channel for more content like this. Thank you so much for watching.